Okay, so in today's lesson, we are focusing on completing the square. So just like when we learned factoring, this is just a tool used to go from one form of quadratic to the other. So if I give you something in standard form, right, which is right here, and if you want to go to vertex form, which we're at this point we're very familiar with, well, to go from here to here, you complete the square. So complete the square, CTS, right, as I write here. So completing the square is a tool used to go from one form to the other. Okay, so in this example, to convert an equation from standard form to vertex, we need a complete square. Then you can graph the equation. And again, the reason we do this is because, as it's saying here, vertex form is easy to graph, right? And as we see, we know the vertex, it's easy to plot that, and then if we know the a value, we know the step pattern going up. So if I give you something in standard form, right, and I want this to go into vertex form, well, the first step to completing the square is you need to factor the a value out. So factor the a value, the a value out of the first two terms. So the first two terms are these ones right here. So you factor the a value out. So this would become y equals, factoring the a means pulling a 2 out, and then that will leave you with x squared minus 4x, close the bracket, and then plus 10. Okay, step 2 is you apply this formula, all right, where you take the b term now, the created b, all right, you take b, you divide it by 2, and then you square it, and then add, subtract this value inside the brackets. And this is the part, this step 2 is honestly the part that a lot of people mess up on, okay? So step 2 says we take this value right here, this value, and that value right there is minus 4, okay? So you take minus 4 divided by 2, square it, all right? So inside the brackets, you would get minus 2. Squaring it, you get 4. So we need to add and subtract that value. You know, so we just have our math working downwards. Let me just put this off to the side over here. So what's going on over here? Again, this is b being divided by 2 and squaring it, all right? So the value that we are adding and subtracting is this 4. And again, inside the bracket. So you have y is 2 x squared minus 4x, and then you are adding and subtracting, adding a 4 and subtracting a 4. Close the bracket, and then 10. And the reason you add or subtract here is because if you add 4 to something, let's say I give you $4, and then I take away that same $4, have I really changed how much money you have? No. So by me adding something and then right away subtracting it, you're not changing the equation at all. But you'll see why this matters, okay? So then step 3, and actually I want to make a point here. I'm going to always point something out. It is always the positive first and then the negative, okay? So you always put the plus here and then the subtraction of that term. So it's always plus and then subtracting. Okay, so step 3, you then take, you then multiply the a value by the negative added term. And then I'm going to put a note to get it out of the brackets, to get it out of the brackets. The brackets. Okay, so what I mean is you take this a value right here, this 2, and you multiply this negative 4 here. And if you multiply that negative 4, so essentially you're distributing that 2 only to that negative 4. So that the 2 still stays in front because you haven't distributed it to this x squared, nor have you multiplied that negative 4x, nor that, I'm going to keep that in red just so you see it, nothing's changed with it. But you've now, on the outside of the brackets, you have this minus 4 multiplied by this 2 and adding this 10, okay? So you've taken that negative 4 and this is being multiplied. This is multiplying right here. All right. Now, what you have created, the reason you needed that plus there and not the negative, all right? So this, if you go back to the previous unit, sorry, my eraser, this right here, this is a perfect square trinomial. And remember, when you have a perfect square trinomial, and how do I know it's perfect square? Because you can take the square root of 4 and get 2, and you can take the square root of the first term. And those squares right there, that x and that 2, when you take 2 times x times 2, you get 4x, which is that middle term there. So again, this is a perfect square. So with a perfect square trinomial, all right, so then step 4, factor using perfect square. Well, that step right there says y equals 2, nothing's changed there, and then that perfect square right there becomes x, and then when you do perfect square, it's, recall from unit 2, this negative right here goes there because there's a negative there, and then you put the square of the second term, and that's all squared. And then on the outside here, you still have this minus 4, 2, plus this 10. So then the last step, step 5, is collect like terms on the outside. And essentially, this becomes your k value. So, step 5, y equals 2 x minus 2 squared. Well, this right here, that is negative 4 times 2 is minus 8, plus 10, that becomes plus 2. So notice now you have it in vertex form. This is y equals a x minus h squared plus k. Here's your k, here's your h, here's your a. And notice how we got there from standard form, okay? So let's do that. Oh, actually, first let's graph it. So we are going to take our vertex form right here. So given it in standard form, we know now this is the same thing, this equation right here is the same thing as y equals 2 x minus 2 squared plus 2. So let's answer these questions based off this equation right here. So direction of opening, DOO. Well, direction of opening, this is going up because the A is positive. All right, the y-intercept. Well, look right here. This is standard form. That's your y-intercept. The c value is your y-intercept on standard form. So in this case, it's 10. Well, actually, I should put in 0, 10. The x-intercepts. All right, well, in this case, what is the x-intercept? Well, we have to factor this. All right, so let's do our math over here. So 0 is 2x minus 2 squared plus 2. So I just set the y to 0. All right, so bring the negative 2 over. So positive 2 over equals 2x minus 2 squared. Divide both sides by 2. That becomes negative 1. So now negative 1 equals x minus 2 squared. Well, take the square root of that. Well, here we have a problem. You can't take the square root of a negative 1. So, none in this case. Okay. Well, the vertex. The vertex is at the point h and k. So 2, 2. The axis symmetry is at x equals h. So x equals 2. The optimal value, all right, your max or your min, well, in this case, it's an opening up. So we have a minimum, at y equals, 2. And then, is it a stretch or compress? Well, in this case, it's a stretch by a factor of 2. Because our a is 2. So let's plot everything we have there. We have the vertex, 2 and 2. So that's right here. We don't have any x-intercepts, but we have a y-intercept, 0, 10, right up here. Okay. If we have our axis of symmetry, that goes right through your vertex, x equals, in this case, 2. Well, you can mirror this point. So this point is 2 off of that. That means it's 2 off of the axis symmetry over here. And there you go. You can just plot that point right there. So here is actually the same graph. Yeah, okay. So you can plot these points right here. Go down to your vertex. And then you come up like this. And there is your graph. This is y equals 2x minus 2 squared plus 2. Alrighty. So let's just practice completing the square and then stating the vertex. Okay, so step 1, all right, so remember this order. We're going to factor, then do the b over 2, multiply the a, factor using perfect square, and then collect like terms. So maybe write this down on a note or like take a picture of this and we can refer to it as we go. But I'll also refer to it as I dictate what I'm doing. So in this case, step 1 talks about taking that a value, factoring that a value out, and only of the first two terms. So it's y equals minus 5. Pull this minus 5 out, so it then becomes x squared minus 2x. Nothing happens with this 1 right back here. Now step 2, all right, so before we do step 2, let's do our math off to the side. So we need to find what b over 2 squared is. So in that case, in this case, it's negative 2 over 2 squared. That's minus 1 squared, or 1. So you add and subtract x squared minus 2x. You add first, so our value here was 1. So add 1, take away 1, because then you're not actually changing anything, plus 1. The next step, take this minus 5, multiply this minus 1, only the minus 1 because you're trying to create a perfect square trinomial. So x squared minus 2x plus 1. And now on the outside, you have that minus 5 times the negative 1, adding that 1. So now this becomes step 4. Use your factoring by perfect square. So this right here, that right there is a perfect square. It will always be a perfect square. If you follow the steps, it's always a perfect square. So this will become x, because this is a negative right here, negative 1 squared. And then on the outside, well, why don't we clean up this step 2? May as well. So that's minus 5 times minus 1, plus 5, plus 1. And now the last step is to collect those like terms on the outside. So y equals minus 5, x minus 1 squared plus 6. And there you go. You can see you have an a of minus 5, a h of 1, and a k of 6. So the question is also asking us to state our vertex. So our vertex is at the point 1, 6. Okay, we got a few more to do. And you start to see the pattern. And maybe if you want, try and pause the video and attempt to do it yourself. Maybe on a scrap piece of paper so you don't actually mess up your notes. But try and attempt it yourself. And then you can play and you can see if you got the correct answer. Because it's just a tool. It's an algorithm essentially you're following. All right. So step 1, factor out the a. Well, in this case, this is much easier. The a value here is 1. So really, there wasn't anything to do here. But if you want to still see it properly, you can still put this bracket because it doesn't change anything. X squared, 8x plus 15. Just remember, you have like technically a 1 here. All right. Well, step 2. Take the b value. So in this case, it's positive 8. So take positive 8. Or I'll just write 8. Divide that by 2. Square it. So that's 4 squared, or 16. Add and subtract that 16. So 8x squared, 8x, plus 16, minus 16, plus 15. All right. Technically, the next step is to then take the a value, and again, there's technically a 1 here. You would multiply that minus 16 here and get it out of the brackets to create your perfect square. So 8x squared plus 8x plus 16. And now on the outside, you have minus 16, or I'll put that in red because that's where it came from, times that 1 that's really in front there. So plus 15. So in future, I won't always write this 1, but I just want you to be able to see where it's coming. All right, step 4. Now use your factoring by perfect square. So this right here makes a perfect square. So you get y is x. And now you see that there is a positive here. So plus 4. And why is that 4? Because the square root of this is 4. Square that. And then on the back side, you have minus 16 plus 15. And then the last step, clean up that k value. I should do that in red. So y equals x plus 4 squared minus 1. Stating the vertex, well, our vertex is at minus 4, minus 1, the h and the k. All right, ooh, fraction this time. All right, don't get scared by the fraction. Process is still the same. So factor out that a value. And in this case, our a is 1/2, right? So you need to factor out a half from the x squared. So you just get an x squared. But then use your calculator. What is 3x? And when you factor out a half, it's like you're taking 3x and dividing it by half. So then if you do that, you would get 6x minus 1. Take your b value, 6, divide it by 2, square it. So that's 3 squared, or 9. So now, second step, take your y equals half x squared plus 6x and add a 9, take away a 9 because you don't want to change it, minus 1. All right, so we're going to be doing some fraction work here. So then take this half. Oh, sorry, I jumped this up, but that is the next step. So now, step 3, take this half, multiply that negative 9 there. So you'll get y equals 1/2 still in front, x squared plus 6x. You keep the positive inside the bracket, the plus 9. And then on the outside now, you have minus 9 multiplied by 1/2, and then you still have that taking 1 away in the back, okay? So step 4, use your perfect square. So 1/2, so factoring this right here, that becomes x, and plus, because it's plus 6, and then the square root of 9 is 3 squared. And then over here you have this right here, negative 9 1/2 becomes negative 9 over 1, or over 2. Or you know what, let's just put it in decimal. So this is minus 9 times 1/2, that's minus 4.5 minus 1. So then you have y equals 1/2 x plus 3 squared minus 5.5. And if you didn't want to put it in a decimal, this would be the same thing as me. So 5.5. 5.5 is the same thing as 11 over 2. Okay? So, same thing. State the vertex now. Vertex is at the coordinate minus 3 because it's positive 3 in the brackets, and then minus 5.5. There you go. If the question said, leave your answer in exact form, well, exact form would be this. This is exact form. Okay? But if it doesn't, then you can put it in a decimal. That works as well. Alrighty. So, same process. Start by factoring out your a. All right, we have a decimal here. So we're going to take 0.2 out, x squared. How many times can 0.2 go into 10? Well, it can go into it. Well, actually, I want to double check. 10 times 0.2 divided by 0.2, sorry. Minus 50x. I thought it was that, but I want to double check. Don't have to restart this video. 0.2 x squared minus 50x, and then plus 650. Okay, so we're dealing with big numbers here, and small because it's a decimal. Okay, now, next step. Take the b value, which is minus 50, divide it by 2, and square it. So you will get minus 25. Square that number, and I'm pretty sure 25 squared is 625. 25 squared, yep, 625. 625. So 625, that's the number you're going to add and subtract inside the brackets. So y equals 0.2 x squared minus 50x, and then plus 625 minus 625 plus 650. Okay, step 3, we're going to have to do that multiplying of the a value. So y equals 0.2 x squared minus 50x, this plus 625 here, but then you're taking this a value and multiplying this minus 625. So actually, we'll do that after, but so you see where the numbers are coming from. 625 multiplied by 0.2 plus 650 on the outside. Step 4, your perfect square. So y is 0.2. X squared minus 50x plus 625 well becomes x. And this right here is a negative. So negative. And the square root of 625 is 625 is 25 because we just did that math before. So 25 squared, right? That's why that squared comes into play. And then let's simplify this too. So 625 times 0.2. 625 times 0.2. 125 plus 650. So then step 5, collect your like terms on the outside there. So y is 0.2 x minus 25 squared. And what would that be? That's 550 plus 525, sorry. 525. And there we go. State your vertex. Well, the vertex is at 25, 5, 2, 5. All right, last question. Example 5. And we now see this completing the square in the context of a word problem. And again, much like the previous lesson, what do the variables actually mean in a word problem? So Judy wants to fence 3 sides of a yard in front of her house. She bought 60 meters of fence and wants to maximize the area she can fence in. The quadratic function f of x equals 60x minus 2x squared, where x is the width of the yard in meters, represents the area to be enclosed. What is the maximum area that can be enclosed? All right. So let's think about what this is actually meaning here. So you have a yard. All right, so you have a yard and you want to close 3 sides. So 3 sides of your yard. Okay, and x is the width of the yard in meters. So where x is the width of the yard in meters represents the area of the quadrant. Okay, so the area here is represented by f of x. And then the width, like the material that's going to be used is these dimensions, x here. So the key thing when you're reading these is like whenever you see the word maximum, okay, in terms of this, what is the maximum area? Well, if you think, if f of x is measuring the area, and you know, on a graph, f of x will look like a quadratic because it's a order 2 here. You're graphing f of x on the y and x on the x-axis. It's asking you for the maximum area. So your brain, you know, survival guy needs to kick in here and be like, oh, well, the max in terms of quadratics is me saying find the vertex. And what this means in the context of this problem is that vertex will have a coordinate where the x value will be the width, and then the y value will be the area. Because again, f of x is measuring the area, and x-axis is measuring the width. So to answer this problem, we need to find the k value of our vertex, because that right there, this right there will be the max area. So let's find the k value of our vertex. So we are given an equation, f of x equals 60x minus 2x squared. So it's a little tricky here because this is not like something we've seen before. Well, in this case, let's rearrange it into something we are familiar with. So I can rewrite this as f of x and just put the minus 2x squared first and then add 60x. And now it looks more like standard form where you have this 0 on the back as your C value, okay? Well, follow your vertex, you're completing the square because we are given this in standard form. This is standard form. So if I want to find the vertex, because again, big picture, I'm looking for the vertex. So complete the square. So step 1, take out the a value here from the first two terms. And in this case, we only have two terms. So it's minus 2x squared minus 30x. Alrighty. Now take that minus 30, divide it by 2, square it. So that's negative 15 squared, and that is 225. So minus 2 x squared minus 30x plus 225 minus 225. All right, next step says to multiply that negative 2 by that negative in the back here. So then you get minus 2 x squared minus 30x plus 225. And then on the back side, it's now minus 225 times negative 2. All right. So then you get minus 2 and complete the square now. So this bracket right here is a perfect square trinomial. So it's x, because this is a negative here, minus square root of 225 is 15. Square it. And then on the back side, it's 225 multiplied by negative 2. So a negative times a negative here, we're going to get 450. So plus 450. And there you go. We can see we have our vertex at 15 and 450. So this right here is the dimension, this is the width, and this is the area. So because this is an application question, give your therefore. So therefore, the maximum area, and we know it's a maximum, not a minimum, because our a value here is negative. Okay, so the maximum area is 450, and what units are we in? Width of the yard in meters. So this would be meters squared. Okay, so the maximum area is 450 meters squared. And there we go. So there is our work that we're going to do in class today, or tomorrow.